Hello students of class 12. So today we'll be continuing with polymers. Today we'll be discussing about preparation of some important polymers. So here what you have to learn is you have to learn the equations properly as well as from which monomeric unit these polymers are prepared. The conditions as well. Okay? So let's begin. So first, today we'll be discussing about preparation of important polymers. Okay, so the first one that we are going to discuss today is polyethylene. Polyethylene. It is also known as what? Polyethylene. Okay, so the monomeric unit that of polyethylene is CH2, that is ethylene or ethene. So whenever this ethene is treated under very high atmospheric pressure, not atmospheric pressure, in fact pressure, okay? So the pressure ranges from 1000 to 5000 atmospheres. This pressure is very high, and in presence of oxygen and temperature around 520 Kelvin, what happens? This n number of molecules of ethylene will come together and form polyethylene. So you get the formation of polyethylene. This is polyethylene. Now, since the pressure here is very high, okay, so this results in the formation of low density polyethylene. So this ethylene that you obtain at very high pressure is what? Low density polyethylene. Now the same ethylene we can obtain from ethylene by treating it at lower pressure. So let's do that. This is A, this is B now. So when this n number molecules of ethylene is treated at low pressure now. Please remember this. The pressure here is very high, and here pressure is only 6 to 7 atmosphere. And in the presence of Ziegler-Natta catalyst. Okay? Ziegler-Natta catalyst. This n number molecules of ethylene or ethene will condense together to give you again the polyethylene. And here the polyethylene that you obtain at low pressure is what? It's just the opposite of this low density. You get here you will be getting very high density polyethylene. So here what you have to remember is these two equations, and please don't forget this condition. And at what conditions of pressure will you obtain low density polyethylene, and at low atmospheric pressure you will be obtaining high density polyethylene. Okay, so now let's move on to the next polymer. The next polymer that we have in our syllabus is polypropylene. So, you know, propylene, the structure of propylene, that is propine. Okay, so here what we have CH3 CH double bond CH2. This is propine. Yes or no? This is propine. Whenever this n number molecules of propine is again treated with catalyst. Which catalyst? Ziegler-Natta catalyst. You have to remember this catalyst. This is very important for polymerization. Ziegler-Natta catalyst. What you obtain? You obtain polypropylene. So you obtain what? You obtain polypropylene. So here you have to be very careful. Now here you will be getting CS2, CS2. Here since the double bond is here, now in the polymeric form, the bonding has to be from this. It has to be bonded from this carbon and this carbon. Carbon number 1 and 2. Not carbon number 3. Because carbon number 3, the valence is already fulfilled. Therefore, it stays as it. So, the chain, the lengthening of the chain, the polymeric chain will be started from this carbon and this carbon, where double bond is present. Okay? So, this you have to remember. And the name of this polymer is what? Polypropylene. Now let's move on to the third one. The third polymer that we are going to discuss about is polystyrene. Styrene. So you have to remember the formula for styrene. The formula for styrene is benzene ring CH double bond CH. So when n number of styrene, okay, they are condensed together, what do you obtain? You obtain polystyrene. CH single bond CH2, and the bonding will be extended to other this styrene to this carbon and this carbon. Okay, and here this n represents what? They are bonded together. So this you have to remember it properly. So here what you observe? You observe that if you know the monomeric form, then you can easily get polymeric form. So you have to remember what these monomers are made of. These polymers, what are the monomers? Okay, and this will be asked in your examination. So now let's move on to the next polymer. That is fourth one. The fourth one is polytetrafluoroethylene. So in short, it is also known as PTFE. Okay, PTFE. So it is P. Polytetrafluoroethylene. So when for this polytetrafluoroethylene, the monomeric unit is CH2 double bond CH2, and whenever n number of this monomeric unit, okay, is condensed at very high pressure and in presence of oxygen. So in presence of very high pressure and in presence of oxygen, this n number molecules of tetrafluoroethylene, they condense together to give you a polytetrafluoroethylene. So you have to remember this, okay? So here we have CH2 single bond CH2. This side the chain will be extended and this side also chain will be extended. And here how many molecules will be linked together here in the chain? N number of molecules. So this is the formula for polytetrafluoroethylene. Now let's discuss the fifth one. The fifth polymer that we are going to discuss is polyvinyl chloride. Polyvinyl chloride. And in short, it is also known as PVC. So polyvinyl chloride is, we have this formula for polyvinyl chloride, CH2, double bond CH, Cl. Okay, this is polyvinyl chloride. Now, whenever polyvinyl chloride and molecules of polyvinyl chloride, this N is very large number, more than 1000. Okay, please remember that. Under pressure and in presence of peroxide, what will happen again? They come together to form a very long chain to give you a polymeric form of this compound. Okay? So how many molecules will be linked together here, this side and this side? And molecules. CH2, CH, Cl, and this side the chain will be extended, and this side also chain will be extended. Same unit will be repeating again and again this side, and same unit will be repeating this side. Okay? So this is the equation which shows how to prepare polyvinyl chloride. Now let's discuss the sixth one. Now here let me tell you, now all these reactions, till now, whatever we have seen, are all what? Addition reactions, which I have taught you yesterday in the previous video. So these are all what? Addition, polymerization. Okay? Now let's discuss about Buna as rubber. The sixth one that we have is Buna as rubber. So Buna as rubber, in short, is also known as what? SBR. It is also known as what? SBR. S stands for styrene, B for butadiene, and R for rubber. So this Buna as rubber, the monomeric units are what? Styrene and butadiene. So let me write the monomeric units. So butadiene, CH2, double bond, CH, single bond, CH, double bond, CH2. This is butadiene, buta, 4 carbons, diene means 2 double bonds. So whenever it is treated with styrene, that is CH, double bond, CH2. As we have done today for polystyrene, this is styrene. So when these two are treated, okay, when these two are treated treated with peroxide, it is treated with peroxide, and the temperature is 273 Kelvin. Okay, 273 Kelvin, and these two are what? emulsified. It is what? emulsified or emulsion. Now what will happen? These two will condense together. How many? What is the number of molecules of butadiene and polystyrene? It is N. So these two will condense together. Now please, you have to be very careful. Now here, let me write the polymeric form. So let me write it here. CH2, single bond, CH, double bond, CH, CH2. Now see how the reaction takes place. This bond will be shifted here, and this will be used in forming polymeric chain. This and this bond will be shifted here. Okay. So here we will be having single bond, double bond here in between. Then we have single bond, single bond. Now this carbon here, this carbon is attached with this carbon which contains the benzene ring. And here we have CH2 and this chain extends. What is the number of molecules? N molecules. So whenever this N molecules of butadiene and N molecules of styrene, they condense together, then they give you what? They give you Buna as rubber. So here I want to rectify something. So in this previous video, where we had learned about this Buna rubber, there the bonding that we have done is from this carbon to this carbon. So which is the correct, but it was given in the book, therefore I just wrote as it was. So please, my apology. Please rectify that mistake. Okay, please rectify that mistake. The correct formula for Buna as rubber is this. The bonding between butadiene has to be from this carbon to this carbon. Okay, and not this carbon, which we had done in previous video. Please rectify that. I am sending you in your WhatsApp number also the correct form. Okay, so this is the formula for what? Buna as rubber. Now let's discuss. This is also what? Can you tell me? This is whether addition polymerization or condensation polymerization. Here, this is also addition polymerization. Because no simple molecules like water or ammonia are being eliminated. So here, this is also what? This is also addition polymerization. Please remember, this is very important. The last thing. Now, the last polymer that we are going to discuss today is Buna. This was Buna as rubber. Now we'll be discussing about Buna and rubber. Buna and rubber. So please don't get confused. This is and rubber. Means natural. So here the starting natural again. One of the starting natural is same, that is butadiene and CH2 double bond CH double bond CH2. Now, here in Buna and rubber, one of the monomeric unit is what? Butadiene. The other one is acrylonitrile. What is acrylonitrile? It is CH2, CH, Cn. So it is acrylonitrile, and this is butadiene. So acrylonitrile. So whenever these two are condensed, then what will happen? They will again exist in polymeric form. An molecule of this, and here also an molecule of acrylonitrile. Whenever they are condensed, we get a polymeric form. This is N. Okay, N number of acrylonitrile. What will happen? Again, as in the previous case, here also you will be having what? Here we have this formula. So here there has to be a double bond. Okay, acrylonitrile. Now again, here the pattern of bonding is same. This will be bonded with this carbon. This bond will be used in the formation of polymeric chain, and this will be sitting here. So let me write this product: CH2, single bond CH, double bond CH, CH2. So I have written this part. Now this is connected to this. So CH2, single bond CH. Here we have Cn, and this will be extended in both of the directions. And how many what is the number of molecules? N. So this is the CH2. 1, 2, 3, 4, 5, 6. So this is the formula for what? Buna and rubber. So with this, we have come to the end of what? Today's discussion. So we'll be discussing about some more important polymers in our next video. Till then, take care. Thank you.